The idea of an elaborate sort of Star Trek-esque kind of hologram form of training is pretty pie in the sky. Do I buy into the romantic vision of what that could be? Yeah, it's cool. It's a cool idea. We don't know what the metaverse is. We certainly don't know what the military metaverse is going to look like. Is it logical to try to do it? Definitely. Is there value in having a shared virtual space where we can do collective training, a shared virtual space that captures data from multiple people and stores that data and uses those data to then make training different the next time? Definitely. Will VR and XR technology be critical to accessing that military metaverse space? Certainly, but it's a long way away. Hello, my name's Sam Vine. I'm a professor of psychology at the University of Exeter, and I'm interested in human performance, training and learning. And I've been talking today about how we might use extended reality technologies like VR to support the education of high performers. I have a particular interest in technology and data and how we use those to try and train better and how we use them to understand performance. So it's conventional psychology, but with a focus on a technology or a technique that gives us a kind of deeper insight into what a human's doing when they're training or when they're performing. So XR is one of those technologies, but the work we do is in others as well, in eye tracking, in data science, in psychophysiological measures. We kind of try to lift the lid on what goes on between the ears and what that leads to within the body to try and make it better. I guess the application of that work, the application of that research is where I've been most successful in my career. So it's good science and it's meaningful science and we extend knowledge, but really we try and take that knowledge out into the field and see if it works. We're not interested in kind of knowing stuff for the sake of it. So what's often referred to as like translational research or impactful research is kind of what we do. So that started at the University of Exeter, where I did a PhD in sports psychology. That then led into other safety critical fields like surgery and aviation, before ending up in the field of the military and defence and security. Which I guess is just another instance where people have to train and to learn and to perform at their best kind of when it matters. I started doing an undergraduate degree in sports science, and the sports science degree is typically the physiology and the biomechanics of human performance. So you learn about sort of cardiovascular system, the muscular system, you learn how the body moves, how we produce action. And towards the end of my degree, there was this sort of add-on of psychology and neuroscience. It was a couple of modules in which we learned a bit about how athletes think and how that might influence the way they perform. And so that was my first, I guess the first interest I had in the idea that the brain and thoughts and emotions are critical to the way we perform. And there's only a limited amount of understanding that we can get from measuring the body and the actions that the body creates. That work then, that sort of conventional psychology of understanding emotions and thinking led into sort of more of a neuroscience interest by looking at specific cognitions and maybe even looking at the way the brain works and maybe even imaging the brain and using techniques like eye tracking to try and have a little insight into how the brain works. So getting into the psychology of performance came from that first sports science degree. And then I stayed at the University of Exeter to do a PhD in skill learning, still in sport. So specifically looking at how novices pick up skills for the first time. And the idea that how you learn a skill initially has a huge impact on how you are able to perform it once you've mastered it. So this idea that some of what matters when you perform under pressure at the very top and the peak of your career is sort of actually embedded in you from a very early stage when you first acquired those skills. So how you learn the skill in your back garden or in your junior football team or coaching that you had at a very young age has a real impact on what happens when you make it to that World Cup final or when you're trying to make that putt on the 18th at Augusta or whatever. And there are several theories that sort of explain why that's the case. And so my PhD was interested in exploring one of those and trying to understand whether we could change that, whether we could make people better. And that was my first move towards technology. So I needed to use quite advanced technology in order to do that research. And I learned a little bit about driving that technology and understanding how it works and the data that come out of those techniques. And those are still present today in my research. We still use eye tracking, we still use some brain imaging techniques to really understand what's going on when someone learns a skill in order to predict what might go wrong when they need to perform it. People still today have very different opinions about the role of sports psychology in helping performance. It's more widely accepted at the elite level. It's widely adopted, it's quite common now, but there are still opinions that are unfavourable about what it might mean to need to see a sports psychologist, what it might suggest about you if you need to engage with a mental health professional or with a performance psychologist. Lots of good work being done by the likes of Ronnie O'Sullivan, Chris Hoy, Jess Ennis, in explaining how they engaged with these people and how that's a positive thing, not just for their performance but sort of for their well-being. So I think the view of sports psychology is changing. But I graduated in 2007, and at that time I would say it wasn't commonplace for there to be a named sports psychologist for a given team. We didn't know that the England rugby team had a sports psychologist. We wouldn't have known about individual golfers or Formula One drivers that engaged with those kinds of people. So that's changed. That's changed significantly since then. And we can see this just in the way that those athletes talk about those people. Those people have gone on to write books and release podcasts all about those experiences with those athletes. So I would say the extreme opinions though still exist. There are still people that sort of overemphasize the importance of what sports psychologists do, and people that harshly belittle and mock the reasons behind needing a sports psychologist and the impact that it can have on outcomes. I think it's the same as any application of science to a performance problem. Like it helps, it works, it contributes, and on some occasions it can be the critical variable that makes the difference, but it's not ever a magic wand solution. It's talked about, it's popularised in the language of marginal gains and the extra 1% or whatever, and there's some truth in that sometimes, but it's that gives it a feel that it's some sort of magic pill that you take to make the difference between being not very good at something and being brilliant at it. Some people view sports psychology as being a protection against the performance decrements that could happen. So not additive in any way, but actually just preventing you from losing a few percent. So I always hear the sort of marginal gains approach, and I talk about it actually as marginal losses. So do sports psychologists add 1% or 2%, or actually do they prevent 1 or 2% being taken away? If you use the analogy of the Sky cycling team and Dave Brailsford and his marginal gains approach with them, you often hear the anecdote of the cyclists taking their pillows with them on tour or to an event so that they sleep better, and this being like a really savvy kind of psychological hack whereby these guys have found a tiny advantage that their other teammates sort of don't have. Well, maybe, and who am I to judge whether that's true or not? But I would suspect it's more likely that intervention actually just prevented a loss, right? You're not adding super sleep, you're reducing the chances of a lack of sleep causing a decrement. So those athletes having that ability to cycle that fast had to be there first. And the interventions that were put in place were designed to protect that core skill, that core talent. It wasn't really adding anything extra. They weren't adding seconds, they were protecting the loss of seconds or milliseconds. And I think that's probably my personal view of sports psychology. You need to be skillful, you need to work hard, you need to train, you need to learn, and you need to be able to perform. We can then put interventions in place that will insulate that and protect that so that you can deliver it when it matters. And actually, if you translate sports psychology into other performance fields, I think the exact same analogy applies. In the military, you need guys that are capable, skillful, trained, dedicated, hardworking. And then we can put things in place that will protect and insulate that and make sure that it happens when we need it. We're not going to find magic instant solutions that's going to take somebody from being average to being brilliant in one intervention. It's just not going to happen. I don't know that the field of sport did necessarily sort of pick up the baton initially and run with it. I think sports psychology is the most popular, common form of psychological support. But if you look at other industries, there have been practices, kind of good and bad, that are also of a similar nature. So if you look in for example, the work of NASA in the 60s and 70s, when they were getting ready for these moon landing missions, they were the first people to really consider human factors, to consider emotions, and to consider sort of human cognitions and human things in preparation for those huge feats. If you look in the military, they're perhaps historically a bad example of considering the human component and the human factor in performance. The human and the human emotions and the human side of being a military person was sort of taken for granted. And it wasn't a feature that was necessarily given a great deal of thought. It was techniques and training and capability and facility that was considered critical. Sports psychology popularised the human factors component, in my view. It made it exciting and interesting because we were able to see celebrities that we wanted to perform well, having perhaps performed badly, get better because of an intervention. There's an argument that people like David Beckham were able to really popularise the impact that public opinion and emotions could have on performance with the saga that followed the 1998 World Cup, when this guy was booed at every stadium in the UK for about 2 years, but was able to overcome that adversity, to perform regardless, to perform well, to go on and captain England. So I think sports psychology was the most common form of performance psychology, and made it digestible by the public, the viewing public. We can draw some analogies with some parts of sport where the psychology of the athlete is sort of taken as a given, it's taken for granted, that sort of through self-selection you must be resilient and tough and dedicated and hardworking and robust in order to be here. So if you take like elite marathon running, there's a real culture there of the top 10 guys in the world are all tough as old boots, and they have control of their emotions, they have control of their feelings, they have the ability to be psychologically ready when the time comes. And what determines who wins the race out of those top 10 is speed of running and physiology and nutrition and preparation. So perhaps the military is comparable to that sort of mindset, where the toughness of the person and the psychological resilience of the person is taken for granted. And then there may be some truth, through a process of selection, you are potentially filtering through to find people that have already been through X number of weeks of training and have been, in the rain for 2 hours running across the Brecon Beacons, or have managed to spend 3 nights in a tent on Salisbury Plain. Perhaps we are able to select out people that are naturally tough. But I guess that doesn't mean that there isn't something extra to be added at a later date that will allow truly elite performance to come through. I think there are plenty of examples where the application of psychology enables a performer to deliver their best, their one-off peak performance. Technology, I guess, is just another tool in a performance psychologist's sort of arsenal. Classically, talking therapies, measurements using things like questionnaires, measurements through observation are what a conventional performance psychologist will do. But technology has enabled that measurement to happen in a completely different way. And certainly the work that I've done has been focused entirely on using technology to try and understand what that person is thinking and feeling and doing, so that the intervention that you put in place is fit for purpose. So it's a tool for measuring and understanding what that person is thinking and feeling and doing, so that you can help them to protect and insulate that performance and help them to deliver it sort of when it matters. So if we look, for example, at eye tracking technology, headsets that you can wear that will tell you where an athlete or a performer is looking. What we're really trying to do there is get an insight into where they're pointing their attention, what's capturing their attention, what they're concentrating on, what is that likely to mean in terms of what they're thinking and what they're feeling. And so it's just a tool to give us an insight into what that athlete was feeling and doing and thinking in that moment. And you can gain that in other ways. You could also gain that by asking them and asking them to report what they're thinking. But eye tracking is quick and easy and gives us irrefutable data and that's important because often these people will argue back about what they thought they were thinking and feeling and doing. So in many ways, technology is what allows us to capture data and evidence of that observation. I mean, we haven't really spoken about extended reality or VR, but it's another form of that, really. It's another form of data capturing technology that's going to deliver an intervention in a way that's better than doing it in an old-fashioned or manual way. And perhaps therein lies the danger, though, because we therefore assume that it's always better and always going to be more exciting to do training with that device, but that might not be the case. VR, by definition, gives you a sort of a form of reality kind of in your hand. You have the ability to put somebody into a really realistic environment, despite them being sort of virtually somewhere else. So that's the primary superpower, I would say. I can recreate situations that are tough to recreate, and I can do it sort of anywhere when needed on demand. And then you dip into sort of some of those other flexibilities and mobilities that VR gives you. You can port that training somewhere else. You can pass it from one group to the next. You can design a training scenario of a location that's really hard to reach. There are multiple reasons why delivering a given training session is difficult, and VR pretty much can, in the right circumstances, overcome all of them. It might be, for example, that a particular training task is highly dangerous. It might not just be of danger to the people receiving the training, but also be dangerous for the people delivering it. And so if we can build a form of training that maintains all of the integrity of that real training, but takes away all of the risk and all of the danger, then that has to be a good thing. Like any form of training, just because it feels real and looks real and is deemed to be realistic, doesn't mean that learning happens. And so a lot of the research that's being done at the moment is to try and understand the distinction between whether the trainee thinks that the training is good and real and effective and high fidelity, and whether actually there are learning outcomes and a change in performance that's meaningful. We know, for example, that you can have really high levels of satisfaction among trainees who report that the training was really viable and really high fidelity, but there's also evidence that they didn't learn anything and that they've got no skills that are actually transferable to the real thing that you were trying to do. If you take learning of a sports skill, like a simple skill of kicking a rugby ball, we know that the end goal is to try and enable people to kick a rugby ball accurately when they are playing in the Six Nations or playing in a World Cup. Kick that goal when it matters to win those points that win the game. And so we try and find a way to train that skill to increase the chances of that thing happening in the future. And so you start to assess what are the hurdles, the factors, the costs associated with designing training that's going to do that well. And on some occasions you might land on technology like XR. You might conclude that in order to create that opportunity where that skill is performed well in the real world, I need this technology to make that happen. But kicking a rugby ball is a good example where that technology would clearly not be viable. It wouldn't be necessary, it wouldn't be optimal to use, because holding a rugby ball on a 10-metre square piece of grass anywhere, or not even a piece of grass, a piece of concrete if necessary, is going to be better practice, is going to be more high fidelity, more realistic than any form of VR rugby kicking anyone could possibly produce. So it's an example where, and there is this push towards VR for sports skills, but it's an example where that push is mind-bogglingly nonsensical, where we don't need to produce VR to teach those skills because those skills are unlikely to get better as a result of that technology. Now the exception to that rule, I guess, is where the performance of that skill, the outcome of that skill is determined by factors other than the ball and the kicking action. So things like the sort of psychological stress that somebody performs under, or the data that you can capture about how they kick the ball that might help them learn more effectively. And on those rare occasions, there may be a role for VR or for XR. So it might be that in learning to kick that rugby ball well, to score those points in that Six Nations game, I need to get really used to the noise of the crowd. I need to get really used to the pressure of opponents charging me down. I need to get used to the adverse conditions, weather, for example, that might be at play. And VR might help me to recreate some of those conditions and those factors. And in doing so, I can learn to be good despite them, and therefore perform well. But that probably makes up a very tiny proportion of what really matters in that given skill. Now, of course, there are other skills in which VR is a clear candidate for being the best solution to that problem. Particularly if we are, as was mentioned earlier, if we're training skills that are too dangerous to simulate in any way, too dangerous to recreate physically in the real world. If we're creating skills that are highly complex and require lots of moving parts, lots of people, lots of facilities, lots of equipment, etc. If we're trying to recreate skills that are that require high levels of measurement, so we want to measure the things that people are doing while they're training, and particularly if we want to do training that is at high volume, right, and at scale with hundreds, if not thousands, if not tens of thousands of people, then clearly VR is a good candidate. So if I want to teach somebody the basic procedures in dismantling a weapon, cleaning that weapon and putting it back together, it might be that for the first 90% of the learning that happens there, VR can achieve that. So I can teach you 90% of that skill, perhaps using VR. Before then I need to do the final 10%, of that training, which would involve you obviously needing to handle a real weapon and get the feel and the dexterity of that weapon. So there are these occasions, these situations where VR is just the perfect tool for being able to deliver that kind of training and that learning at scale to multiple people. It's likely that VR will be a cost-effective way of delivering some of those complex training situations. So if you look at the costs associated with building a virtual reality vehicle of any kind and compare that to the cost of building a synthetic, fully operational version of that vehicle, then very likely that VR will be cheaper. And the fact that VR training facility can be copied and pasted onto multiple headsets, used at multiple sites, again is going to add to the sort of scalability of VR and the cost effectiveness of it. But again, for me to play devil's advocate, there are occasions when VR is a more expensive solution to a training problem. There are plenty of examples where training that was delivered en masse via a 1-hour PowerPoint presentation that's now being delivered by a complex, highly expensive form of VR. That's clearly an example where the training isn't cheaper. People are bargaining on the fact that training will be better. And so that the initial cost of doing that training that way leads to benefits further down the line in terms of improved learning and less fallout from training, or maybe less injury from training. So it's another complex seesaw of decision making, and I'm not sure that any industry really has got a good grasp of the sort of economics of XR just yet, and for good reason, because we don't really know yet what particular XR works for what particular training problem. We certainly don't know really fully how much it costs, because we haven't seen any XR really delivered at scale yet, and any real sort of retrospective analysis being done of whether that was the most efficient way of doing it. So that the jury's out there, I think. Is there the potential for XR to be a highly cost-effective way? Definitely. But do we need to be very careful about when we apply that to get it right so that we achieve those gains? Yeah, absolutely. And our work has been really focused on helping people to make good decisions about both whether XR is the most effective tool to get the most learning and the most training, but also whether it's the most efficient tool. And in the equation of efficiency comes the cost, unfortunately. XR headsets provide, or VR headsets provide, endless streams of really useful data. It's like you've sort of fully digitized the human being that you're training. You're able to understand, where they're pointing their head, how they're moving their hands. You're able to measure things like heart rate if you have the right headsets. Every single behavior that they adopt in VR is literally digitized and is recorded. So you have this wealth of information about a trainee when they're in an XR headset. And that's probably one of the most potentially valuable features of XR training. Eye tracking is another one of those data streams, but in my view it's arguably the most sort of powerful and the most useful. Our research has certainly shown a number of ways that we can take those eye tracking data that those VR headsets provide and get really meaningful impacts on the rate of learning, really good detailed understanding of what the person was doing within the VR environment, really good markers of when expertise has been reached, and even attempts at trying to understand the kind of emotion and the psychological status of the user. And what's interesting is that all of those things I've just mentioned, they're all things that good trainers are kind of able to do anyway in the real world. A decent sort of coach or a decent trainer is able to understand what their trainee is thinking, whether their trainee is up to a certain standard, whether their trainee is producing the right kind of behaviours that suggest they've been learning. And so eye tracking is a way, and some of the other data streams, is really a way of automating a lot of that human intelligence and allowing the technology that's on the trainee's head to do it for them. Now, if you start to combine some of those different data streams and bump them together, so if you look at how the person moved and behaved, where they looked and what they concentrated on, and combine that with all the different performance scores that you get, let's say it's a shooting VR tool, accuracy and efficiency of shot, you have this super rich field of data that trainees and trainers can use to make sure that those guys get as good as they can be. And for me, that's the most exciting thing about XR in the military defence and security space, is that data richness that we will have. That's where I think XR can have such a powerful effect. If you look at the most successful conventional simulators that the military use, if you look at flight simulators, if you look at dismounted combat type simulators, if you look even at some of the clinical or medical simulations that have come across from healthcare into the military, they're all characterized by not just having sort of high fidelity or high usability, they have all got really complex measurement techniques kind of built into them, really detailed ways of understanding how that person behaved, how they performed, what the outcome of their actions in those simulators were. And VR does all of that, but also allows it to become useful in skills other than just those where we've spent £20 million building a facility somewhere. It sort of puts all of that on the road. It puts that into the hands of more people, I think. Most obvious use case for the data that we capture from XR, VR technology is to try and use it to keep people in their sort of in their zone of optimal functioning, at their challenge point. This is what we are always trying to do when we're designing learning and when we're designing training, is to stretch people just enough that they're going to improve, not so far that they give up, and not too little that they aren't improving, but that sweet spot in the middle. And so yes, we can use those data to do just that. Computationally live, in the moment, we can assess whether this person is likely to be at that optimal level, or just below it, or just above it, and adapt that situation to bring it into that sweet spot. And there obviously is a danger that we might use those data in a way that will not be the right thing for the trainee. Is it good that I can understand everything that my trainee is doing in a training situation, and should I be making decisions based on those data that might be meaningless in the real world when push comes to shove? So we have to be cautious with those data, much the way that we will have to be cautious with any data that we capture from virtual environments that attempt to explain why a person is doing something. We might be wrong, and so there always needs to be the human back in that system to contextualize it and add some human judgment to any decisions that the machines are making. There are certainly examples from other industries where that exact thing is happening, where people are trying to recreate the sort of psychosocial difficulties of a scenario, the stress, the fatigue, the temperature, whatever it might be, replicate those and use those for training. But whether that's been done in a military setting, I don't know. I would say though it's commonly talked about, right, and it's touted as probably the most useful and meaningful application of this technology. But I do suspect that certainly when we've tried to generate research or studies on that principle, you come up against some real difficulties. Technical difficulties in actually being successful in manipulating the level of stress that the person feels, and obviously moral difficulties in understanding whether that was the right thing to do in the first place. But again, conventional training is designed often to push people to limits and push them to maximums that are representative of what they're likely to face in the real world. And so I think if we're using XR in order to do that better or easier or cheaper, then I think that's okay. But those, if XR enables us to do that better than we can currently do it, then there are new moral questions about how far we should allow XR to push people. If I can genuinely convince somebody using XR that they are, at height in enclosed spaces, under threat, then should I be using it? Is that morally okay? That's as important a question as to whether it's actually effective at making them into a better person, a better performer. The idea of an elaborate sort of Star Trek-esque kind of hologram form of training is pretty pie in the sky, and I think the metaverse, the military metaverse, sits quite close to that. It's not likely to happen anytime soon, and that's because no one really knows what it's supposed to be or what it is. But if we step back from the language of military metaverse for a little while, and imagine that there's going to be a sort of a digital home for military defence and security training to be housed within and happen from and be recorded within a central hub, then yes, hopefully. I think it will still be quite a long time before that's realised. And I think the last thing that will happen within that digital hub will be stuff that sounds like the military metaverse, will be the virtual training worlds, the shared virtual spaces where we can meet with NATO colleagues to do a shared virtual training exercise. I think that will be the last set of things to happen in that digital training sort of revolution. But we really don't know what the metaverse is. We certainly don't know what the military metaverse is going to look like. Every problem and concern and hurdle that there is with the metaverse is amplified when it becomes the military metaverse. And so there are real challenges. Do I buy into the romantic vision of what that could be? Yeah, it's cool. It's a cool idea. And is it logical to try to do it? Definitely. Is there value in having a shared virtual space where we can do collective training? A shared virtual space that captures data from multiple people and stores that data and uses those data to then make training different the next time? Definitely. Will VR and XR technology be critical to accessing that military metaverse space? Certainly. But it's a long way away. And all of the hurdles in the way are quite boring ones from the perspective of a neuroscientist and a psychologist. They are data security, data management, socio-political things that are nothing to do with whether it's a good idea or whether it's going to have a meaningful impact on a human. So I'll sit tight for now and wait until the lawyers and the politicians sort of sort that problem out. But once it's launched and it's live, I'll be the first person there to try and understand how we use it well to create effective people and to deliver really good training and really good learning. The human in the system is still critical and in my view always will be. Any machine, including virtual reality or XR for training, is an additional tool that's going to help the human deliver what humans are good at delivering. That's decision making and skillful performance and good moral judgment on situations. And so to think that VR, XR, AI will ever replace that is, in my opinion, silly.